Hello, welcome back. So we're going to now move along with our chi-square test of association to see whether there's an association between race and receiving a callback in this experimental study with resumes. And we're gonna next move into the check and calculate steps. And so for the check step, we still have this independence assumption like we usually do. And just as a reminder that this is an assumption of independence of the observations, not the variables. And so the question we want to ask with this is each application providing completely new information. All right, so you could take a second to kind of think about that. And so you could really kind of argue either way, but for this case, I'm going to argue yes. It doesn't seem um, like knowing whether the first applicant in the data set received a callback. So it doesn't seem like that tells us anything about the chance that the next applicant receives a callback. So I'm taking the argument that each application is providing us with a distinct separate piece of information, and that information is unrelated. Okay, so we also have the sample size condition. So this follows a really similar pattern of our last two hypothesis tests, where we had an independence assumption and then we had some sort of sample size condition. So that was first the success failure condition, and then for the chi-square goodness of fit, that was a condition on the expected counts. This is going to be really similar to the chi-square goodness of fit test, where we want to check that all expected counts are larger than 5. The big difference is going to be how these expected counts are actually calculated. And so they're going to be computed a bit differently for this chi-square test of association. And so to talk about that, we're going to break it up into this smaller example, just because the numbers will be a bit easier to work with. And so we'll have a little bit better understanding of what's really going on. And so for our expected counts, we're just going to try to find what we would expect our counts to be if the null hypothesis were true. In this case, the null hypothesis is that there's no association between the two variables. And so if that's true, what would you expect your counts to be? We're going to suppose that we have this fake data set based on, with one variable being sex and the other variable being whether or not the person received a promotion. And so these are our observed counts, and what we want to do is find the expected counts for each of these cells if sex and receiving a promotion were actually not associated. Okay, so let's start by just filling in our column totals and our row totals. And then the total number of people in this data set is 15. And then let's do a couple calculations to make sense of what these expected counts are. And so the proportion of all people who receive a promotion in this example, it looks like that's 5 that received the promotion divided by 15 total people. And so it's a third is the proportion of people who received a promotion in this example. And then the logic is that if there really was no association between gender and promotion, then we would expect about a third of the males in our sample, so that's where the 5 out of 15 plays in, and a third of the females in our sample to get a promotion. Based on this logic, take a second to think about, you can go ahead and pause the video, how many males we would expect to get a promotion if our null hypothesis of no association was true. All right, so there's 6 males in our sample, and so if there's no association, then we would expect a third of the males to get a promotion. And so that means we would expect 2 males to end up getting a promotion if there was no association. We could make the same calculation for the 9 females. And if there were no association, we would expect 3 of the female job workers in this example to get a promotion. Okay, and so now these are the expected counts for these 2 cells in our table. We want to try to figure out a general formula now for these expected counts, just something that's a little bit easier so we don't have to fully think through this logic each and every time. But the logic is here so that these expected counts don't just pop out of nowhere, and now we've made sense of them a little bit. For our general formula, it's actually a little bit easier to see if you don't reduce the 5/15ths to 1/3. And so really what we did was this calculation is the same. And so from here, you should be able to kind of reason through that the expected count for an individual cell, so let's focus on this one first, so the yes male cell, that's going to be, based on our little formula up here, that's going to be the row total times the column total, so that's the 5, divided by the 15. I call it the total, but it's really just the total number of applicants, or the total number of workers. All right, and so we could repeat this for each of these 4 cells to get the 4 different expected counts if there were no association between sex and getting a promotion. All right, and so going back to our callback example, which is the data that we're actually interested in, we could repeat this calculation for white applicants who get a callback. And so we want to find the expected count first for this particular cell using the formula that we just reasoned out up here. I'm going to take the row total, 2,435, divided by the column total, which is 392, divided by the total number of applicants, which we actually didn't calculate before. So let's go ahead and do that. So divided by 4,870. So we can go ahead and figure that out to get 196 applicants is the number that we would expect to get a callback if there were actually no association. Again, it's hard to see why that's true for this example where the numbers get so big, but we worked through this kind of easier example just to see the logic behind why this formula actually gives us the expected count if we assume no association. All right, we could do the same thing for Black applicants who did not get a callback. And so going back to my table, I'm going to do, so Black applicants who didn't get a callback, the row total is 2,435. Column total is 4,478. And the total is 4,870. And so if you do this calculation, you should wind up with 2,239 applicants. So what we could do is actually build a table of expected counts. And I want to keep it in the same order and format as our table of observed counts so we could easily compare later. And so I'm going to put the no and yes on the columns to match here, and then black, white to match the rows. I'm going to fill in the 2,239 that we calculated for Black applicants who didn't get a callback, and I'm going to fill in the 196 for the white applicants who did get a callback in this bottom right. And so take a second to go ahead and pause the video and practice calculating these other two expected counts. So the expected count for white applicants who didn't get a callback and the expected count for Black applicants who did get a callback, assuming no association. All right, and so let's see. So I got 196 and 2239. These won't always be the same. So I guess here will always be the same. The reason that they are the same for this example is that the row totals are identical. So the 2,435 and 2,435, there were the same number of applicants in each race that sent in resumes. That won't always be the case though. And so if that wasn't the case, then you would wind up with 4 different expected counts here. Okay, so I know I'm over my usual 10-minute mark goal, so I'll leave it here. But as always, feel free to shoot me an email if you have any questions about any of this.